All right, hello. This is one of the questions from the electric fields worksheet. We're looking at question one and how to work through this question. So we're told that two charges are separated by a 10 centimeter um, separation distance, and that whatever the charges on these two-point charges are, it creates a force of 3.0 times 10 to the negative 6 newtons between them. What force results from each of the following changes considered independently or separately? So this is essentially, when you see questions like this, it's a proportionality question. What we know before we even get into part A, B, or C is that generally a force is equal to k q1 q2 over d squared. And in this case, we don't know q1 or q2, but we know that we're okay with the fact that for some k, and so k is constant, for some q1, for some q2 at a distance of 10 centimeters, we know that there is a force of 3.0 times 10 to the negative 6 newtons. So it's saying at some charge for q1 and some charge for q2, some very specific charges, which we'll now call q1 and q2, at a distance of d, which is, for us, d is referring to 10 centimeters, we know that the force is 3.0 times 10 to the negative 6. So now we're asked to consider a new case. And in this case, we're asked, well, what is the force when we have doubled the charges and the distance remains the same? So instead of q1, it's now going to be 2 times q1 because q1 has doubled. And the same thing is true for q2. It's now 2 times q2. And our distance remains the same. Well, this is equal to k times 2 times q1 times 2 times q2. So we can pull all the constants out in front and say 2 times 2 is 4. And pull that out in front. What I'm left with then is the k, q1, q2. So far so good. And we know that this is equal to 4 times k q1 q2 over d squared. But if we look at this here, and we look at what we stated at the very beginning, what this question told us, we'll see those are the same thing. So this is equal to 4 times 3.0 times 10 to the negative 6 newtons. And our new force for A is going to be, take a quick look here, 1.2 times 10 to the negative 5 newtons. Now for part B, in this case the charges have remained the same and the separation is increased to 30 centimeters. So from 10 centimeters to 30 centimeters, what's happening? Well, from 10 we have to multiply by 3 to get to 30. So we have 3d instead of 1d. So in this question we're going to get the force is equal to k q1 q2 over 3d squared, which is equal to k q1 q2 over, well, in this case 3d squared is 9d squared equals 1/9 of k q1 q2 over d squared, which again we can take this and substitute it and go 1/9 times 3.0 times 10 to the negative 6 equals 3.33 times 10 to the negative 7 newtons. And number C. Right, I'm trying to kind of running out of room here, so I'm going to try to conserve some room. In this case, our force is going to be equal to, it says, the charge on the one sphere is doubled, only one of them. We can pick which one we want. So that represents the one charge being doubled, while the distance is halved. Okay, so Q2 remains the same, and I have a half of d squared, which is going to be equal to 2k Q1 Q2 over a quarter of d squared. This is equal to 8k Q1 Q2 over d squared. We've seen from before, this is equal to 8 times 3.0 times 10 to the negative 6, which is equal to 2.4 times 10 to the negative 5 newtons. Those are the answers for A, B, and C right there.